In section 3, we're going to be talking about circles. As we begin this, we're going to review classifying conics. So we're going to classify these 7 different conics. Our first one, I'm going to highlight the important things to focus on. Both x squared and y squared are positive. They both have the same coefficients. So as a result, this is a circle. On the second one, x squared and y squared are both positives, but they have different coefficients in the front. So that is going to be an ellipse. Our third one, x squared and y squared, one is positive, one is negative, but they are both squareds. So that is going to be a hyperbola. Number 4, we only have one squared term, so that's a parabola. Number 5, x squared and y squared are both positive, both have a coefficient of 1, so that's a circle. Number 6, only x squared exists, so that once again is a parabola. And number 7, x squared and y squared are positive. They both have the same number, so that is a circle. So that's just a little review of our classifying conics. Let's look down to our circle. For those of you who may remember back from geometry, the standard form of a circle formula is x minus h squared plus y minus k squared equals r squared. Now, with that being said, the center is h comma k and r equals the radius. So let's graph this first one. Before we graph on each of these, we need to identify the center, which is 2, 1, and the radius, which is 3. So we're going to graph the point 2, 1, and then from that point we're going to go out 3 units in each direction. And we're going to draw a circle from those 3 points. So there's our first equation. Our second one, our center is at the point -2, 3 with a radius of 2. So we're going to put our center at -2, 3. And then we're going to go out with a radius of 2 from this point. So I'm going to go 2 in each direction. We're going to draw our circle with radius 2. There we go. So that's how you're going to graph a line, a circle with radius 2. Please remember when you finish that you really shouldn't consider those 2 dots in the middle. They are just reference locations that we're going to work off of. Now, what if it's not in standard form? Then what we're going to need to do is we're going to need to complete the square to transform it into standard form. So to do that, we're going to have to do what we did with parabolas and kind of work through this. So on this one, we're going to need to have x squared minus 4x plus blank plus y squared minus 6y plus blank. And this is going to be equal to our original problem of -9. But we're going to need to add in the blank from the x squared addition and the blank from the y squared addition. Half of -4 is -2, squared is 4. So we're going to add 4 to both sides on the first blank. Half of -6 is 3, 3 squared is 9, so we're going to add 9 to both equations. Now we're going to write this as binomial squared. So x minus 2 squared plus y minus 3 squared equals 4, because the 9's cancel out. This is going to give us a center of 2, 3 and a radius of 2. So let's sketch that. 2, 3 with a radius of 2. There we are. Okay, let's look down at example 5. Here we have x squared plus 8x plus blank plus y squared minus 2y plus blank equals, and I'm going to move that negative 8 over, I'm going to move the 8 over, making it negative. And I'm going to put my blanks back in. There's my blank for my x squareds. There's my blank for my y squareds. Half of 8 is 4, squared is 16, so we add 16 to both sides. Half of negative 2 is negative 1, squared is 1, so we add 1 to both sides. That gives us x plus 4 squared plus y minus 1 squared equals negative 8 plus 16 is 8, plus 1 is 9, giving us a final result of a center of our circle at negative 4, 1 with a radius of 3. So let's sketch that. Negative 4, 1 with a radius of 3. I find if you put the extra points at the 45-degree angles, it helps your graph look more like a circle and less like a diamond. All right, let's look at our last one. This is kind of creatively put on here, just to kind of make sure you understand. You see it's 2x squared and 2y squared. That's still a circle, but since the coefficients in the front of each are 2, I'm going to divide the whole equation by 2 to make this easier to start with. Now I'm going to complete the square. And we intentionally do not have anything here with the x squared, and so that's just going to be x minus h. And so as I work through this, I brought the 3 over and made it negative. What we're going to add to both sides is a positive 4, giving us x squared plus y minus 2 squared equals 1. So our radius is 1, and our center is 0, 2. So let's sketch that. 0, 2 with a radius of 1, very small circle going through there. So here we have examples of how to complete the square with 2 different variables at the same time, and then also just how to identify the standard form of a circle. Reminder that we need to continue to review so we can classify our conics based just on the standard form of the problems. I've placed the examples down here at the bottom. I'd suggest you maybe use the graphs when you're doing this. One of the problems in the bottom does reference the distance formula. If you remember the distance formula, let me just kind of review that with you. The distance formula used the idea of the change in x squared minus the change in y squared. So here we have the change in x squared plus the change in y squared. You took the square root of the whole thing. And so you're going to probably have to find the distance between these points and the origin, and that's going to give you the radius. And then once you have that point, then you can easily work the problem out from there.